Hello and welcome to the June update from the Tau team. It's on to the developers. Over to you, Karim.
Thank you, Fala, and welcome everyone to the Tau development team update for the month of June 2024. Let's start with Umar this time. Umar finished a major implementation of general trees layered on top of binary trees using the left child right sibling construction, LCRS, known as LCRS. And the implication of this new implementation is that it reduces the complexity of memory allocation in all of our trees from linear down to algorithmic. And that is a big change. It's very significant improvement. He's also completed the garbage collection of tree nodes as well. And now he's working on other improvements and optimizations for the manipulations of tree operations in general, which would make our parser much more performant. Andre has been working diligently on the architecture of the Tau testnet. He's been analyzing and comparing the architecture of several other blockchain projects like Solana and Aptos. He's also been continuing his work on the Twitter to Diagram bot that he's been working on for a few months now. But the goal is to better enhance community engagements. And he has also enhanced website security and through a comprehensive vulnerability assessment. And he's also added a robust backup system to our website. Tomáš has been splitting his time between working on core Tau language features and general development support for all of our developers. On the Tau core language side, he started working on finding a fixed point of recurrence relations, which is something similar to what we were doing in TML, and it's kind of his area of expertise, and it's very core to Tau language. He's also made some syntax changes for the constant types in Tau language, and he's done some work on rewriting or moving the rewriting rules into the parser. On the general development tasks, he's been resolving some issues with GitHub. He assisted Umar on fixing some template bugs on his side. He's also fixed some issues with GCC 14, which is the C++ compiler. And he's created a script, a helper script to help with the testing of parser library in the Tau database. He's also continued to update the parser documentation for everybody. David, on his side, took time from his busy schedule to work on demos for you guys. He first wrote a script to run all the demos in a robust and repeatable way. He then recorded it in the form of a video that some of you may have already seen. His main task this month has been to wrap up the strong normalization of Tau formulas. In particular, he made several changes to simplify the code and create an API that will later be used by the execution layer. Now he is thoroughly testing the strong normalization. He'll probably take another week doing that with some back and forth between him and Ohad, making sure that the strong normalization works really well because it's foundational for the Tau language. He has also made some changes to the Tau language syntax itself to improve readability of Tau programs, and he's updated the REPL also. Last but not least, Lucca has finished many tasks both on the core Tau language, but also on the theoretical front with Ohad and Dr. Franconi. So he finished the substitution algorithm in the REPL. He also implemented the new Boolean function normalization algorithm. He also added grammar support for uninterpreted constants in the Tau language. And he performed some work in supporting the keywords called sometimes and always in the Tau language. He's also been studying the satisfiability algorithm, which is the next big task on his plate. On the theoretical side, he reviewed the alternative formulation chapter in the Taba document by Ohad, which itself is presenting an improved satisfiability algorithm for Boolean combinations of models and Tau formulas. That's it for the Tau development team. See you guys next month.
All right, fantastic. Thanks, Karim. And now I'll pass it over to Lucca for his update this month.
Yeah, thank you, Fola. So as Karim mentioned, I finished the substitution algorithm. So just to show you a quick example, we're taking this formula, we are taking it to demonstrate the capability of the substitution algorithm. And that is, you can see in the first part of the formula that for all x exists y, such that not x or y is unequal to 0, that the x is quantified. So if we substitute, this x should not be replaced. Then we have the next part, which is and x, y is equal to z. Here x appears as a free variable, so it should be replaced. And then at the end we have or all v, x and v is equal to 0. So there x should also be replaced. Now we are using the special memory command that David implemented. So this percentage means we are getting the last inputted formula. And we want to replace x by v plus w. Now note that v in the last part of the formula is quantified. So something needs to change. Otherwise, we are substituting the v plus w into a quantified scope, which is not correct. So if we press enter, we can see that in the first part of the formula, nothing changed, just as we wanted. In the second part, the x was just replaced by the v plus w. And in the last part, you can see that the for all v was changed to for all x2 in order to account for the fact that the thing to be substituted included the variable v. So this basically shows the capability of the substitution algorithm. And then regarding the second task I finished this month, involved normalization of constants within Tau formulas. Constants can be Tau formulas themselves. So we are working with this formula. So whenever you see an opening a curly bracket, that means we are entering a constant. And as you can see, we are then inputting a Tau formula as a constant. So what this formula basically says that, let's see, we have that for all x exists y, such that x and y is equal to 1, and then this constant exists x is equal to 1, unequal to 0, and if all of this is unequal to 0, in this case means that there exists a model. And the question mark there means that if exists a model, I want the output at timestamp 0 to be 1. Otherwise, I want the output at timestamp 0 to be 0. And now if we normalize this expression also with the memory command, we will see that we just get that the output at time 0 is equal to 0. This is because exists x such that x is equal to 0 is trivially true, which makes this whole end true. And for this reason, the whole formula, the first part of the formula, all x exists y such that xy is equal to 1, that is actually evaluating to false, because it's not true that for all x exists something that makes it equal to 1, because you could take x equals 0, so this turns out to be false. So the whole thing is false, which results in the O10 equals 0 part. Now maybe I hope this is clear if you review this. Otherwise, as I said in the Q&A, please ask questions about formalism. We are happy to answer them. And the rest of the update for this month from me revolved around studying the satisfiability algorithm for tau formulas, which included a thorough review of Ohad's newest ideas and algorithm for this task. We think we nailed it down, which is awesome. And then on another front, we are working on incorporating the keywords sometimes and always into the tau language. And I've been working on getting this change ready. And right now I'm working on correct algorithms to normalize those keywords. So thank you very much, and I'll pass it back to Fola.
Truly incredible stuff. Thank you so much, Lucca. Yeah, really brilliant. And yeah, looking forward to the next updates. I'll pass it over to David for his update this month. Over to you.
Thank you, Fola. Hi, everyone. I have spent the month with the following task. Most of the time preparing videos to demo the updates of the tau language, and to do so, I have created several scripts to easy the recordings. And also I have made several changes into the tau language and also the REPL itself. In particular, the changes were related to the commands history and also the definitions. And also they were related to how we deal with the history, how we reference the history in an absolute or a relative way. I have made another few changes in the syntax of the tau language to have a clear negation for tau formulas. And all those points are demonstrated in the videos that we have shared the previous week or the beginning of this one. In particular, the first video named Basic Syntax and History, so the key points of the history, how to deal with it, and how to properly work. And the second one named Command History, so how we could use the history in the commands, as Lucca has done. Apart from that, I've been working in the strong normalization of formulas. I have made several changes to simplify the code and also allow to properly execute it in conjunction with the execution API. Now I'm testing and debugging it. And also I have made minor fixes in min-ter normal form because I have found a bug is fixed, and I have added the corresponding test to check it. And that's all for my month. Thank you.
Fantastic work, David. As always, a pleasure to hear from you. And we're looking forward to all the updates that you got for us coming in the next coming months. And I'll pass it over to Tomáš for his update.
Thank you, Fola. And hello, everyone. This month, I've been working on the parser and also the tau language. I can show you something. So I fixed the parser compilation in GCC 14, which is GCC is a C compiler, by using composition instead of inherence. And then I created a script. It's a helper script which helps me to test. Anytime I do any change in the parser, I need to be sure that it does not break the tau language, because it depends on the parsing library. So I've created this script which uses my current parser code base, and it runs all the tau tests with this code base. So I'm sure that when I commit these parser changes, it won't break the tau library or the tau language library. Then we got some issues on our parser repository. So I was working on this, and I fixed that. The main issue was that the start directive which says to parser what is the starting symbol. It was not working, so I fixed that. And then I've updated the documentation and the README of the parser library to update it for the latest changes in it and all the new changes in the Tau grammar form. It should be now complete regarding all the features we have in the parsing library. I also did some initial work on enhancing the parser and Tau grammar form to improve rewriting, namely to support rewriting rules. So currently in the Tau code we have these rules which they rewrite the parse tree and do a lot of transformations of the parse tree. And we would like to move these rules into the parser. So I took all these rules and rewrote them to a proposed syntax for these rules. And I started on making this work right in the parser and make them available to any program, like for example Tau language, that it can use it. I've been also working on syntax change for the type of the constant. This is like the proposed change, and I'm still working on this issue. Like the main task of this month was to implement finding of fixed point of recurrence relations. So yeah, I've created this code, and I can show examples. Here is a recurrence relation. At the time 0 it's true, at time 1 it's also true. So when we ask for a fixed point, then it tries to enumerate these states, like steps 0, 1, and so on, and once it finds a fixed point, then it just returns the fixed point. So you can see the fixed point was found at step 1 because at step 0 is a true, and at step 1 is also true. So it does not change, and it converges to true. I can show you some other example. So this is, for example, recurrence relation which does not have a fixed point, and it ends up in a loop, because in an initial state it's true, and next state it negates the previous state, so it's false, and then again in another state, in the following state, it's again true. So when I run this, it should detect that it's a loop. And for now, we just return false when we detect the loop, but later there will be more options, including some fallbacks. And maybe another example. Here is an example with the recurrence relation which does not have the initial condition. And when I run it, it finds the fixed point, that it's the initial condition, and X. That's all from me. Thank you.
Amazing. Fantastic there, Tomáš. And I'm sure the community will enjoy having a look at what is possible and seeing some of those updates there. So thank you so much for sharing that. And last but not least, I'll pass it over to Ohad for his update this month.
So I've been working on refining and understanding better the results I spoke about from last month, and also how to extend the Tau language to be able to specify not only software like it does right now, but also a whole network of computers, with each of them running Tau software. So a global picture of a whole network of computers, so you can reason how the network behaves as a whole, and of course it should be very useful for blockchain. And the first results look very good, and I hope it will continue this way.
All right, fantastic. Thanks so much, Ohad, and thanks so much to the team, and thanks to you guys for tuning in into our team updates every month. We love the questions that come after. And we'll see you guys on Telegram and on X. Cheers.